So when we look at electron configuration, we divide the periodic table into blocks, and you see that depicted here with numbers and letters. These two columns are the S block. The middle, the transition metals, these are the D block, are metalloids, poor metals, and nonmetals, and noble gases. These make up the P block, except helium, which is part of the S block, helium only being 1s in configuration. And then on the bottom, the lanthanides and the actinides, these are the F block elements, which, by the way, these two rows, if you've ever wondered, they actually belong right here where I'm pointing. If you were to wedge open the periodic table at this point, these two rows would go here and here. To save space when we print periodic tables, we often put them at the bottom. But this is the F block of the table. Now, the letters correspond to our sublevels within the primary energy level. For instance, here's the fourth energy level, and this is the S sublevel with the S orbital. Now, in each block, the letter corresponds to the highest energy orbitals, the highest energy sublevel of that atom. For instance, silicon, which is right here, its highest energy sublevel is 3p, third primary energy level, is p sublevel. And in that sublevel, silicon has 2 electrons. Now keep in mind the Aufbau principle. In addition to the 3p, silicon also has all the lower energy levels and sublevels going all the way back to the 1s. So silicon, the electrons, are configured into the 1s, 2s, 2p, 3s, and then 3p energy levels and sublevels. And again, that's when silicon is in what we call the ground state, meaning none of the electrons have been excited up to higher energy levels. So those are the blocks of the periodic table.